Good day, students. I am Engineer Maurice Aquino. I will be your instructor in this subject. This is Engineering Economics. And as you may know, on our group chat, I already sent you the course outline together with the grading system and the course policies. Okay? And then this day, we're going to talk about the first chapter of our lesson, of our subject. That would be the introduction to engineering economy. So, first, what is engineering? Defined by Abbott, accreditation for engineering and technology as the profession in which the knowledge gained in physics, chemistry, life sciences, and mathematics is applied to make products in large scale that increase the proper prosperity of man. This must be achieved with a judicious choice of materials at lowest cost in a manner that is benign to the environment and that keeps all the stakeholders safe. So based from this definition, the engineers uses different knowledges, different knowledge. From physics, chemistry, life science, and mathematics, because engineers don't just do things as they want to do it. They use they use these tools to analyze which is the best decision to use. And it is said here that projects or things must be made by engineers with judicious choice of materials at lowest cost. So in order to do that, we need to study economics. So what is economics? Oh God. Economics is the study of how to allocate resources efficiently to satisfy unlimited human wants, how individuals and societies choose to use scarce resources. As we all know, the earth or our world has a very limited resources. And even as a human, we have limited resources, specifically financially. Even as the day we struggle. That's why the purpose of economics is it helps us to what they call this it do this that it allocates resources. It helps us choose which thing to do, which decision to make. Okay, because as what said here, it satisfies unlimited human wants. All the humans have unlimited wants. So the next is we combine the two. What is now engineering economics? It is now the application of economic factors and criteria to evaluate alternatives by computing a specific measure of worth of estimate cash flow over a specific period of time. So engineering economics is the combination of both engineering and economics. So it means that in the engineering profession, we are using economy. We use this different economic methods in terms of decision making, in terms of what they call this, choosing the right material, doing the right solutions. That is engineering economics. Okay, so under economy, we are considering three main or major resources, namely land, labor, and capital. Resources are the things we use in order to proceed or in order to continue what do you call this, doing what's need to be done. Let's talk each one. Land. Land is these are all the gifts of God, such as water, air, minerals, sunshine, plants, trees, tree growth, and itself, which is applied to the product. Land itself, which is applied to the production process. So land. So as a resources, for example, I am an engineer. I need resources to do things. And one of those resources that I am using is under land. For example, let's take example as the civil engineers. They use some of these resources specifically under land to do buildings. They use land itself as the site or as the location to put up buildings. Next is that they use different minerals, for example, cement, woods, or yeah, they use it as resources. And next one is labor. What is labor? The effort, skills, and knowledge of people which are applied to the production process. So that's another resources. You cannot build something without those people who's gonna build it. Okay, that's for under labor. Next is capital. Under capital, we have three. Technically, capital refer to it's like the fuel of your project or your venture. Like number one, real capital. Those are the tools, the buildings, machineries, things which have been produced which are used in further production. Next is the financial capital, assets and money which are used in the production process. Human capital, education and training applied to labor and production process. So these three are your resources in production. And these are the things that we use economics for. We cannot just use whatever resources we have. We need to apply economics in order to preserve them or in order for it to last. But there's also this thing that they call in engineering the sustainability, wherein in order for us, we engineer must preserve or must use those resources wisely so that the next generation will still have some left or they can still use these resources. So in economics, we use this, we economic help us to preserve or use this properly. Next is the principles of engineering economics. Number one, develop alternatives, focus on the difference, use consistent viewpoint, use a common unit of measure, consider all relevant criteria, make uncertainty explicit, revisit your decision. Okay, so these are the things that it's like the process of engineering economy. So let's see the first one. Develop alternatives. The final choice or decision is among the alternatives. Alternatives need to be identified and then defined for subsequent analysis. So it's like um, you're trying to make something and you list all the possible methods or it says alternatives. For example, you all had your programming, right? For example, I'm making a program. I'm making a software. And I will list all the plans or all the alternatives that I'm going to use. Whether I'm going to use C++ as a language, C Sharp, Java, Python. Those are the first thing that I will list or I will think about. Those are the alternatives. The next is focus on the differences. Only the differences in expected future outcomes among the alternatives are relevant to their comparison and should be considered in the decision. Okay, so example, we already list all those programming languages. Next is that we focus on its differences. For example, C Sharp is owned now by Microsoft, and C Sharp is already C Sharp supports all the Microsoft platform easily. It is the deployment is easy, the installation is easy because it is owned by Microsoft. That's one thing to consider in the focusing on the differences. Like well, Java is open source and it's kind of bit it's since it's open source it makes it a bit complicated, but it runs on all devices you can imagine or all the platform. So we should consider another is differences. Next is use a consistent viewpoint. The prospective outcome of the alternatives, economic and others, should be consistently developed from a defined viewpoint or perspective. One example is you compare those things at as at a same viewpoint. For example, you're going to make a program using these different languages. Which one, let's say you will just think of the compatibility with different devices. Which one will produce the most compatible what do you call this? Most compatible software. Example, C sharp like may require a higher specification, or Python may require lower specification. You compare things at an equal criteria. Next is use common unit of measure. Using common unit of measurement to enumerate as many of the prospective outcome as possible will make easier the analysis and comparison of alternatives. So, use common unit of measures. For example, on the efficiency, um, if this efficiency or the speed of the program we should all use the same unit so that comparison would be easier. Next is consider all relevant criteria. Selection of preferred alternative decision making requires the use of criterion or several criteria. The decision process should consider the outcomes, enumerate in the monetary unit and those expressed in some other units of measurement or made explicit in a descriptive manner. So you're not just gonna what do you call this? Think of one certain criteria and compare all the alternatives. You should think of all the criteria that are possible. For example, I am going to build a computer, a personal computer. So I am trying to think what processor to use. I'm comparing an Intel processor and an AMD processor. So we all know that um, Intel processors are more expensive than the AMD processor. So we're not just gonna think about their prices. Because if we think about their prices, one will always win. There are also other criterias that should be considered. For example, is the durability or the what do you call this? The efficiency. It is said that Intel is more efficient than AMD in general, AMD processors in general. And it is said that what do you call this? Yeah, just like that. I won't gonna add anything because I might be sued. Okay, so consider all the relevant criteria, not just stay on one criteria, so that the decision that you will come up with is going to be uh, unbiased. Okay. Next one is make uncertainty explicit. Uncertainty is inherent in project or estimating the future outcome of the alternatives and should be recognized in their analysis comparison. So, uncertainty, there's always an uncertainty or parang, what do you call this? Kids. Those are the risk that you're going to take, and you should recognize it, which one is risky, which one is not, or what, in your analysis or comparison. The next is revisit your decision. This is the last actually. Improve decision making result from an adaptive process to the extent of practicable practicable the initial projected outcome of the selected alternative should be subsequently compared with actual result achieved. So okay, for example, you already deploy or you already bought or use the project, should revisit your decision if you made the right decision or you made the right computation because uh, you will still do another what do you call this decision making again, and reviewing your previous decision will make yourself better. You will see that um, it is said here that improved decision making result from an adaptive process. So by repeating, by reviewing your decision, it will improve. Okay, get me? Next, engineering economy and the design process. An engineering economy student is accomplished using structured procedure and mathematical modeling techniques. The economic results are then used in a decision situation that involves two or more alternatives and normally includes other engineering knowledge and inputs. So in the design process or in designing this decision analysis or this cost analysis, we engineers use mathematical techniques or mathematical modeling and apply different engineering knowledge in order to in order for our decision making to be successful. Okay, so here it is. The first in the engineering economics analysis procedure is the problem recognition, formulation, and evaluation, development of feasible alternatives, development of cash flow for each alternatives, selection of criterion or criteria, analysis and comparison of alternatives, selection of the preferred alternatives, performance monitoring, and post-evaluation. Let's back for a bit. So, this procedure is where this is the step by step, as I've discussed earlier. You identify the problem, You develop the possible alternatives or the solution. You develop a cash flow. The cash flow is like a diagram or a figure wherein it shows where you spend your money, and there's the what do you call this, the return of the money. It's like that. It's the flow of the monetary flow in your project. Next is the selection of criterion. So after making the cash flow, you select the criterion. Okay, the parts or the characteristics that you will compare the alternatives. The analysis now, we proceed to the analysis using the cash flow and the criterion, selection of preferred alternatives, and the performance monitoring. So of course, after we decide, for example, we use the cash flow we made already the cash flow in the alternatives. Let's say one of the choices or one of the alternatives, uh, what do you call this, provides a lower expense, but we consider the criteria on how efficient the product is. For example, though it gives us a lower expense, even though it should also give us good efficiency. Example, I'm going to buy a computer. It has a low price, but it has this problem wherein the material that comprised or that was used is not that durable, and it would it may broke any time. So I won't choose that alternative because it's going to be more of my loss than gain. Did you get me? It's like this in economic analysis, we're not just considering about the costs or the pricing. We consider different criteria, and then we arrive into one answer or one alternative. Okay? Next is this. Last of the slide. Counting and engineering economy studies. Modern cost accounting may satisfy any or all of the following objectives. Determining the cost of products or services. Provide a rational basis for pricing goods or services. Provide a means for controlling expenditures. Provide information on which operating decisions may be based and the results evaluated. Okay, so these are the accounting and engineering economy studies. So this is the objectives in accounting. We determine the cost, of course, that's one of the thing. Provide a rational basis for pricing goods. So after determining the cost, we consider the if the pricing is right, or if the price is really what do you call this, it's enough for that goods or service, if it's not overpriced or what. So we provide the means for controlling expenditures, and we provide information in which the operating decision is maybe based on the result evaluated. Okay, so that is our first lesson. And if you have any questions or clarification, you may just message in our group chat, or if you have any, you call this, comments regarding the topic. Okay, to summarize it, engineering economy or engineering economics is the combination of engineering and economy or economics, wherein it combines both things to be what do you call this? Combines it combines the thing to for us engineers to be more efficient or more productive in to be more good or to be better in more to be better in choosing an alternatives or in decision making. That's all.